Welcome to Mafia, a new podcast telling stories of America's criminal underworld.
Gotti assumed the position of head of the Gambino family.
And using the name Donnie Brasco, I was able to infiltrate the Bonanno crime family in New York City.
Bugsy Siegel is an American mob legend.
One man changed the whole texture and landscape of crime in America.
Listen to Mafia every Wednesday on Apple Podcasts or wherever you get your favorite shows.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the astronomy podcast known as Space Nuts. My name's Andrew Dunkley, and with me, as always, is Dr. Fred Watson from the Australian Astronomical Observatory. Hi, Fred.
Hey, the original Space Nuts.
Yes.
How are you doing, Andrew?
I'm well, very well. Yeah, I think we've been doing this for 18 months or so now.
Yeah, that's right. I know.
Yeah.
It's
But, you know, if you go back to when we were doing it on radio, it's...
oh, look.
20 years?
It's before the origin of the universe.
Yes, that's right. Yes, yes. Now, today, Fred, we're going to be talking about twinkling quasars, which it sounds rather interesting. I don't know much about them, but I'm sure once you've explained it, everyone will be an expert. And we're going to try and find some lost satellites, which could be a big problem in the scheme of things. And we've had some questions from Brad in Indiana, who only recently discovered us, and it's prompted a few thoughts in his mind, so we might see if we can solve his questions a little later. But first, Fred, twinkling quasars. What indeed are twinkling quasars, and where do we find them? I'm guessing in space.
That's absolutely right, yes. And in fact, a long way away in space, because the thing about quasars is they are generally very distant objects. That's an interesting aspect because we don't really see quasars in the nearby universe. And what that's telling us is that they are kind of extinct now. Quasars are no longer phenomena that seem to occur. They seem to be very much the property of fairly youthful galaxies. So I sometimes call quasars delinquent galaxies because what they are is young galaxies which have a very voracious an active black hole at their center. The black hole is gobbling up lots of gas and dust and probably a few baby stars as well in a swirling disk of material around it. And as this stuff swirls around, the material emits a number of different kinds of radiation, X-rays, for example, infrared rays, and most notably radio waves. And so quasars have been observed, in fact, they were first discovered by observing them with radio telescopes. So this is a story about very distant objects in the universe being observed with radio telescopes. We don't really need to know more about the quasars. What's more interesting is what happens to their radio waves as they make their way to Earth. Because we've known for a number of years, well, probably 30 years, that quasars, when we observe them with radio telescopes, they twinkle in the sky. And by that, I mean their brightness, their radio brightness rises and falls over matters of a few hours. And it's a kind of analog of the twinkling that we see when we look at stars. Stand outside in Dubbo or Sydney or Indiana or wherever you happen to be, you will, especially if you see stars low down on the horizon, you'll often see them twinkling. Then that twinkle is not a property of the star itself. It's caused by the fact that the light has come through the Earth's atmosphere. The Earth's atmosphere is turbulent. It's got pockets of warm and cold air in it. And they basically focus and defocus the light from the star, causing the twinkling effect. It's very, very pretty, although it's the death knell for astronomers.
Yeah, well, it's kind of dispelled a myth I always believed as a kid. I don't know who told me, but they said if it's twinkling, it's a star. If it's not twinkling, it's a planet. Now,
there's a degree of truth in that.
Is that right?
Yes, because particularly the larger planets like Jupiter and Saturn, they tend not to twinkle. And the reason, it's a complicated reason, but it's because they have, unlike a star, which is effectively a point source, a point of light, planets have actually what we call an angular diameter. They have a size, if you point a telescope at them, you can actually see a disk. And what that does is it inhibits the twinkling. The exception to that is Mercury, which is a small planet and is often seen low down in the sky. I've seen Mercury twinkling many times, so you can't guarantee that a non-twinkling object is a planet, but it's certainly true for Saturn and Jupiter. Anyway, going back to the twinkling, as I said, it's caused by this disturbance in the atmosphere. Now, the twinkling of quasars is caused by a kind of analogous thing. It's as the radiation from the quasar passes through pockets of warmer and cooler gas in our own galaxy. Now, the gas between the stars, we call it the interstellar medium, that is very rarefied. It's not sort of high-pressure gas like the Earth's atmosphere. It's a very, very tenuous gas, but it's still, there's enough of it to have this twinkling effect on the radiation coming from quasars. So much has been sort of reasonably well understood. But what is more puzzling is that from time to time, one or two quasars seem to exhibit sudden and quite rare outbursts of really violent twinkling, where their brightness increases dramatically and decreases dramatically. It's called violent twinkling. That's what they give this the term to it. So it's a very almost startling effect, which has not been understood. So what's now happened is a group of scientists, principally in Sydney, in fact, although there are collaborators in the USA as well, they've used one of the Australian radio telescopes, the Australia Telescope Compact Array, to look at twinkling stars, twinkling quasars, and analyze the way the twinkles work. And they can tell that what's happening is the radiation is passing through not a sort of blob of warmer material in the interstellar medium, but something that's shaped much more like a piece of spaghetti, something long and thin, as the radiation passes through it. The next thing they did was decided they'd have a look at these quasars with an optical telescope, one that uses visible light. In fact, they were planning to use the Keck telescope in Hawaii. But as soon as they did that, they realized that their twinkling quasar was very close to a bright star, a fairly youthful bright star, actually a hot star by the name of Al-Kahim. It's a bright enough star that it's got an Arabic name. It was known to early people. Wow. And then they realized that another twinkling quasar is close in the sky to another bright young star, actually the star Vega, which is also a hot star. So they've suddenly twigged the fact that these quasars, they're not close in space to these stars, but their line of sight is close to these hot stars. And that kind of caused them to think about whether these stars themselves might have something around them that is actually disturbing the light of the quasar. And to cut a long story short, they've built this theory that suggests that these stars have almost like spikes of material coming from them. In fact, it's slightly, I'm describing it in a slightly incorrect way, because what they envisage is blobs of material coming from these young stars, which have got a long trail streaming out behind them, and that's being blown away by the ultraviolet radiation from the star. So if you imagine all these spikes of material kind of pointing inwards towards the star, that is what they're hypothesizing. That would certainly solve the quasar twinkling problem. However, that's news to most stellar scientists, that's to say the people who study stars, because while we expect to see these inward pointing filaments, we only expect to see them in very old stars that are surrounded by a cloud of gas known as a planetary nebula. We see many examples of that. So it's a kind of a step in the dark to postulate that these things appear around young stars as well. They're too faint to be seen. We can only detect them by the quasar twinkling. So it's a very nice piece of work, which is sure to set a lot of people debating whether it's actually the fact or not. But twinkling quasars, it sounds like good news to me.
And as always with a new astronomical discovery, a whole array of new questions now need to be asked and answered. So it's a never-ending cycle, isn't it?
It is, that's right. So a discovery like this will indeed prompt a lot of research, particularly among the star community, because astronomy is divided into different branches, who'll be looking at these things in detail and saying, how can we make stars do that? So a lot of work to come.
Okay. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Okay, Fred, let's see if we can find some lost satellites which are making the news at the moment. What kind of satellites are we talking about?
Baby ones.
Little ones, CubeSats?
Yeah, little ones. The CubeSats, that's right. So these are very much the trend in space science because these things, which are about the size of a loaf of bread, are relatively cheap to make and to develop. They don't cost hundreds of millions of dollars. They do cost hundreds of thousands of dollars, though. It's still quite a high-tech business. But CubeSats like this are starting to become useful for all kinds of environmental research, to try and understand the atmosphere of the Earth at very high levels, and other applications as well. So you might remember about, I suppose, a month or so ago, in fact, in May this year, a whole tranche of 28 of these little things were deployed from the International Space Station. Mm-hmm. They included 3 spacecraft, 3 little baby satellites made by scientists in Australia at University of New South Wales, University of Sydney, and the Australian National University. There may have been other collaborators as well. So 3 of those all went into space. They were all deployed, and then they all disappeared, which kind of upset people quite a lot. The last thing you want to do is spend a few years of your life building something that's taken into space and then never seen again.
Yeah, it's not something that hasn't happened before either.
Absolutely
major
right.
Catastrophes here and there.
Indeed.
So, what's the theory?
Well, so that's exactly what the guys did. The engineers who were working on these satellites decided that what had probably happened was that there had not been enough power to deploy the solar panels, which of course provide more power. Right. And so whilst these things were probably emitting radio signals, they were probably very weak. And so what they did was set about a search to try and find a big radio dish that could be used to try and detect their errant spacecraft. And there's a long story attached to that, but they wound up talking to a radio amateur who was is a Dutchman who had access to a very large and essentially now redundant radio telescope in the Netherlands. And he volunteered to help them find their missing spacecraft using this radio dish. The problem was that he has a 9-to-5 job, so he could only do it on Saturdays. And so they had to wait. They had to wait till Saturday. But actually, it worked. They found the first of their missing missing satellites. They picked it up with the radio telescope. They were able to deploy the solar panels, and now it's in perfect working order. But they couldn't find the others. So
and how many are we talking about?
They had 3.
Okay.
They had 3, yeah. So the first one was Tick. That, of course, encouraged these guys. They were ecstatic about that, as you would be. Yeah. And so then they, set off then looking for the next one. And this defeated them. It basically... They couldn't find it at all, and what they started wondering was whether they were pointing this Saturday antenna in the right place in the sky. They're tracked by the North American Aerospace Defense Command, or NORAD. That's where the data comes from as to where they are, and they track everything that's bigger than a few inches across, including the CubeSats. And they were telling them to point at a particular place in the sky, but there was nothing there. But apparently, somebody thought, well, I wonder if they've mixed up the labeling of the satellites or something like that.
Oh.
So they looked down the list of other satellites that had been launched at the same time, and they pointed their Dutch antenna to what was labeled as the University of Colorado's CubeSat, and found a weak signal from their CubeSat, from their own one. So it had been misidentified. The Australian one had been given the label University of Colorado, and so they hadn't even bothered looking at it because they thought it was the wrong satellite.
You've got to wonder how that could happen.
Yeah, it's a bit of a worry, isn't it? Because it's the Defence Radar Command as well. Never mind, we won't go there. But that, yeah, and they found once again a weak signal that was from their own satellite, University of New South Wales, in fact. So what they did was they basically the next Saturday, they had to kind of wait until Saturdays to do all this. Yes. They sent a signal up, deployed it, and away it goes. That's the second one has been found.
Okay.
The jury is still out on the third one. They haven't found that yet. So
the aliens have got that one.
Well, maybe, or it's on its way to Mars or something like that. I don't know. But 2 out of 3 is not bad going, considering that they had a score of 0 out of 3 to start with.
Yeah.
So it's a lovely story and speaks of Australian and Dutch ingenuity, which are things that I think are fantastic.
Yeah, so there's a Dutch-Australian collaboration in my family. My wife is of Dutch heritage, so
there you go.
There you go. Absolutely nothing to do with what you're talking about. Just remind us again what these CubeSats are supposed to be doing up there. Is this the atmospheric analysis?
I think that's
project?
right. I think it's correct. They're looking at the Earth's ionosphere, the high atmosphere region. So very useful scientific work, basically.
And are they planning to send up any more?
I think they will be. It's a fairly big job doing one of these things. As I said, it's not cheap either. It's hundreds of thousands of dollars. One of the things about these CubeSats is that they decay fairly quickly in terms of their orbit. So they're not littering space with a lot of space junk. They're in orbits that will bring them back down to Earth in actually a matter of months, I think. So time is of the essence in trying to get these things going. You know, if you've got a problem like this, you don't want to be dawdling.
No, but now that they've figured it out, they'll probably get it right next time, we hope.
One would hope so, yeah, that's right.
All right. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
What a matchup! And what a team, Mike. Metro PCS and the iPhone SE for $0 on a network that covers 99% of people in the U.S. Oh, impressive.
Play with the best. Switch to Metro PCS and get a 32-gig iPhone SE for $0. Metro PCS. Coverage not available in some areas, plus sales tax and $10 activation fee. Claim based on talk and text. Not valid for active numbers currently on a T-Mobile network or active on Metro PCS in the past 90 days. See store for details and terms and conditions.
0G and I feel fine.
Space Nuts.
Finally, Fred, some questions from the Peanut Gallery. Well, we're Space Nuts, so they can be peanuts. Why not? And Brad from Indiana has got in touch with us after recently discovering the podcast. He's got 2 questions, and we might as well see if we can solve both his problems. He's firstly asking, what do you think is beyond the outside of space? Is there more space, or is there space inside another space inside another one, or something to that effect? Now, you and I have actually discussed this little problem before, and the question may be answered by the potential for multiple universes. And I do remember recently reading that they may have actually found evidence of that, but that's still speculation. But no, what is there space outside space? What's outside space, Fred?
Look, speculation is the right word for this, because we really don't know. You're right about the idea of multiple universes, but let me just describe what the sort of basic model of the universe is. What you might call a standard model, which includes a Big Bang at the beginning. That means that at that instant, the instant of the Big Bang, not only the material of the universe was created, but space itself was created as well, and time. That's right. So that's T0, the Big Bang. What that means is that all of space is sort of enclosed in a universe which started off at that specific time, and there isn't anything defined beyond it. And indeed, the main measurements that we can make suggest that the universe is in fact the same in all directions. There's no obvious place where there's more of it than somewhere else. There are clusters of galaxies and things like that. generally speaking, we assume that the universe is the same in all directions. We can detect that. We can also detect that it's expanding and that the expansion is getting faster. We also can see a horizon. That's to say, there is a region beyond which we can not see. And so, in a sense, the first bit of Brad's question is correct. What is beyond the outside of space? Is there more space? Well, if you say, that the horizon represents what we can see, and beyond that there is an invisible region, well, we do believe that beyond that there is more space, because we think the universe is much bigger than just this bubble within which we sit that we can see. But I suppose what you might call contemporary thinking has a number of ideas that suggest that maybe that's not the full story, that perhaps our universe is just one of many universes which sit in some sort of higher dimensional space, what Doctor Who calls the void, but what physicists actually call the bulk. This is some sort of higher dimensional space with different universes in it. That idea, I think, has lost a bit of its appeal over the last decade or so, but a number of other ideas suggest that there is a single universe, but with little kind of miniature universes within it, of which ours is one, that you've got this whole expanse of stuff.
Like a bag full of marbles.
Like a bag full of marbles, but each marble sort of joins on in a funny way to the next one. These are really very difficult models to test. And as you said, there was some evidence of perhaps of another universe leaving its imprint on what we call the cosmic microwave background radiation. This is the flash of the Big Bang, which we can still see. It has patterns on it from which we can learn a lot. And it has been suggested that a cold region in that area of the sky perhaps is due to a collision the universe a long time ago. These are things that are very, very difficult to prove. Perhaps gravitational wave astronomy will allow us to understand whether there are other universes, because it is possible that gravitational radiation, if you could call it that, in other words, gravity, actually leaks out of universes and might be able to cross the void between one universe and another. So we might eventually find out that, yes, there are other universes around. At the moment, it's pure speculation.
Yes, wouldn't it be fascinating, though? There's so much to learn and so little time. Now,
exactly.
to part two of Brad's question, with the new James Webb Telescope, will we be able to see past the last galaxy that the Hubble took a photo of a while back? Can it reach out that far? And that's the substance of his question. How far past the last galaxy can we see? Can we see past there at all?
So unlike the last of Brad's questions, this one has a very short answer, which is yes. The James Webb Telescope will, like the Hubble, it has the advantage of being above the Earth's atmosphere. It's in space. It gets a very clear view of the universe. But unlike the Hubble, it's a big telescope. It's got a 6.5 meter diameter mirror. The Hubble is 2.4 meters. So it will see much fainter objects. Therefore, it will see beyond the limits that the Hubble telescope set. And in fact, we expect the James Webb Space Telescope to be able to detect, by looking back in time, which is what you do when you look out into space, to be able to detect the first galaxies that formed in the universe. And, we're all looking forward to it very much. It's going to be a project that will tell us much, much more about the universe that we live in, and hopefully give Space Nuts and the Peanut Gallery many, many more opportunities to interact in the future.
Yes,
Thanks
indeed.
very much for your questions, Brad. They're excellent questions, and it's great to receive them.
Yes, indeed. We do appreciate it. Fred, thank you so much. Nice to talk to you as always.
And you too, Andrew. We'll speak again soon.
I hope so. Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley. Thank you for listening to Space Nuts every week. We certainly do appreciate it, and we love your feedback, and we certainly love your questions. So you can pipe them through to us via the World Wide Web on our Facebook page, and we'll do our best to answer them for you, either on the podcast or directly through Facebook page. We answer some of them there as well. And don't forget to tell your friends about us. Don't forget Space Time with Stuart Gary, our sister podcast, available through most podcasting platforms, Audio Boom, Stitcher, Apple Podcasts. The list is long. And keep on listening. We'll catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.
Welcome to Mafia, a new podcast telling stories of America's criminal underworld.
Gotti assumed the position of head of the Gambino family.
And using the name Donnie Brasco, I was able to infiltrate the Bonanno crime family in New York City.
Bugsy Siegel is an American mob legend.
One man changed the whole texture and landscape of crime in America.
Listen to Mafia every Wednesday on Apple Podcasts or wherever you get your favorite shows.